Hi everyone, I'm Kevin Shoemaker. I will be guiding you in this population viability analysis short course for NRES 421 Conservation Biology. I am very excited to be doing this. I've done this a few years. This is, of course, the first time I'm doing it online in my guest bedroom, but here we go. Before we get started on the population viability analysis concepts and building some actual population viability analysis models, I wanted to just introduce you to the tool that we'll be using. It's called Insight Maker. Insight Maker is a pretty powerful online free tool for systems modeling, that is, modeling complex dynamic systems and putting lots of different pieces together and trying to understand how a system is going to behave. Now, what is a system? You can model almost anything with Insight Maker. You can model water, the water flow through a system. You can model carbon. You can model energy flow through a system, but we're going to be using it to model populations. So we're going to consider the population of whatever species we're interested in modeling to be the system that we're modeling. And the concept of stock and flow is central to the way Insight Maker works. A stock is a box that contains stuff, and a flow is whatever changes the amount of stuff in that box. The box for us is going to represent a wild population. So the stock is a wild population, and a flow represents anything that can change that population. So it's going to be births, deaths, immigration, emigration. So those types of processes. All right, enough of that. Let's get started with Insight Maker. All right, I'm going to shut off my video so you can see my computer display. And I want you to go to a browser, your favorite browser. And in that browser, in the URL, just type in insightmaker.com. And that will bring you to this tool. All right. So when you first load up Insight Maker, it'll look something like this. The first thing you need to do is if you haven't already made an account, it's free again, and I promise, they're not going to send you spam emails or anything. So create a free account. If you haven't already, make a username, put in your email. You just need a password and just confirm that you are indeed not a robot, and create an account. And once you have created an account, you can go to the login screen, and I already have an account, so I'm just going to put in my account information and log in. And so take a minute to set up an account and to log in to Insight Maker. You please pause the video if you need to. Once you do get into Insight Maker, it'll look something like this. You see a tab that'll probably for you be blank because you may not have developed any Insight Maker models yet, but once you do save your own Insight Maker models, you can see them here and you can load them at a future date, and you can learn a little more about me here, but you can make your own home account for Insight Maker. These insights generally, these models are called insights in this framework, are generally public, and you can actually access my insights here, but you can also go to this Explore Insights to learn more, and it's kind of a good idea just to see what this is all about, what types of models you will be able to develop in Insight Maker. It's kind of a cool thing to do. I'll search here for world, because I want a model of the whole world, because I'm very ambitious and I would like to conquer it. So here we go. You have to, in order to conquer something, you have to understand it. Here it is. So here's a model of the whole world, and let's pull that up. And it's complicated, but the world is a complicated place. Obviously, I'm being a little tongue-in-cheek here, but this is a very complex model. And what this model happens to be a model of the global population and the impact of humans on the global environment, and also looking at the limits to human growth. And so if you run this model, and I won't talk too much about it, but you can actually run it. Just hit simulate. You can actually run this world model, and you can see that here's non-renewable resources going down as the human population here in green goes up, and this blue line over here represents persistent pollution. So we're looking at the impact of humans, we're looking at the total humans on Earth, and we're looking at the amount of non-renewable resources and kind of the limit to growth of the human population by, this model says, around 2020, 2025, 2030 maybe, the human population will reach its maximum and will start to decline after that point. Of course, this is just a model. So anyway, let's go back. So what I'd like you to do is to start a new insight. You're going to make a new model. Just hit create new insight, and you'll get a screen that looks something like this. You'll get this demo model here, which is kind of maybe the first time you do it. It's kind of a good thing to read through this. It gives you some tips and pointers about how to build a model and about sharing your models with others. But I'm going to skip over this for now. Just hit click this yellow space to clear the demo. And now you have a blank workspace. All right. So we've signed up, we've logged in, we've gotten a blank workspace in front of us. Now it's time to start our first model. All right, so like I said, Insight Maker uses a stock and flow modeling paradigm. That's how models in Insight Maker work. And the basis of this is the idea of a stock. This is just a box that holds things. So let's first add a stock into our workspace. Here's our new stock. We can name it whatever we want. I can call this stock number 1. And if I hit enter, you'll see that shows up on the screen. I can move the stock around. Right now it's just an empty stock. By default, it has 0 units of stuff in it. A stock is just a container that holds stuff. If I want to change that value, I can hit that. I did that a little too fast. There's a little equal sign that pops up when you move your cursor over the stock. Just click on that equal sign, and you can change the value in the stock, and I'll change it to 10. And just hit apply. And you can see that initial value over here is now changed to 10. You can actually change that here too if you want. So there you go. So you have a stock. Let's make another stock. Let's just add another stock over here, and I'll move it over, and this will be stock number 2. I'll just rename it over here, stock number 2. And just know that if you click on the white space, you see all that stuff that you saw over here in the right-hand panel kind of goes away. But all you have to do to get it back is to click back on the stock, and you'll see you can change its name, you can change its initial value, and there's some other things you can do. So now we have 2 stocks. One is starting off at a value of 10, and one is starting off at a value of 0. Now, stocks, the value within a stock cannot change unless there's something called a flow. So let's add a flow into this system. And we're going to represent flow of material, whatever it is, from stock 1 into stock 2. All right, so we have to draw a flow. Just make sure this flow transitions button is highlighted there. And then you can, when you hover your cursor over stock 1, you'll see this arrow. Just drag across until you can see the green highlighting of stock 2. It means that we're going to connect. So then you can release your mouse button, and now you have a flow that connects stock 1 and stock 2. Now, if you click on the flow, you can actually see that there's a field called flow rate, which is the rate at which material is flowing from stock 1 into stock 2, and it's 0 right now. So that's not going to be very interesting. There is no flow. But we can change that. So we could either hover over that flow and hit that equals sign, and we can change that to, say, 0.5. So we have material flowing from stock 1 to stock 2 at a rate of 0.5 per time step. And I can hit apply. All right. And let's see how this model looks if we run it. All we have to do to run the model is to go up to the simulate button and click run. And there you go. So there's 2 stocks. You can see there's stock 1, which starts off at 10 and goes down to 0. And we also have stock 2, which starts off at 0 and goes up to 10 by the end of 20 years. So by default, Insight Maker is going to run the model for 20 years, and it's going to display whatever stocks you have defined on your workspace. What if I want to run it for 50 years? Well, it's pretty easy to do that because I can just go up to the settings button at the top, and where it says simulation length, I just change that to whatever I want. In this case, 50 years. And I can hit apply. And now, if I run it, I just hit the simulate button. It runs for 50 years. One thing you notice when I do this is that stock 1 starts off at 10 and it gets to 0, but then it keeps going. It goes negative. Now, in many cases, material can't go negative. So the stock really can't go negative. And when we start thinking of stocks as wild populations really can't go negative. It doesn't really make sense. So one thing we can do to modify this is when you click on the stock, it has another field that says allow negatives. Let's change that to no. So now we cannot allow negative numbers in a stock. So if it gets to 0, it can't go any lower than that. And if you do that, let's just do that with stock 2 as well, because we're going to want to do this with our wild populations as well, just to make sure that these values don't go negative. So remember, just click on the stock, and that's when you see this appear on the right, because if you just click on the white space, that goes away. So click on the stock, and then where it says allow negatives, say no. And then we can run it again, and we can see that once stock 1 reaches 0 and it's completely drained of all material and it's donated all its material into stock 2, which is the blue line, then it just stays at 0, and that's often more realistic for these models. All right, so that's basic stock and flow modeling. It's about as simple a stock and flow model as you can get. Let's now start transitioning to talk about stocks as wild populations. So I'm going to get rid of stock 2 here, and I can keep just a stock and a flow, but let's change the name of the stock so that it represents a wild population now. So let's make this, I'm just going to make something up. It's going to be squirrels. So we're going to model this population of squirrels, and we have a flow rate. Now the flow in this case is going into the background, into the ether. That can represent deaths, essentially. You have living squirrels in this stock, and when they flow out, they no longer exist. They're dead squirrels. All right? And so we, again, now at this point, the flow rate is in units of individuals, so we don't want this to be fractional. Let's make this equal to 1. So, and we can change the name of this flow to make it more representative of what we're actually doing. This is deaths. So we have squirrels and we have squirrel deaths, And we start the squirrel population off. Let's start it off at a bigger value of 100. All right. And just click back on the white space, and then we can simulate this squirrel population. And you can see it is declining at a rate of, you guessed it, 1 squirrel per year over 50 years. And again, I could change that 50-year time frame to be whatever I want it to be. But here we go. We have squirrels just declining linearly over time. Now, the first thing we're going to talk about when we start talking more about concepts in population modeling is that it's not really realistic to have a linear rate of decline here, that when the population is 100, you lose 1 squirrel per year, and when the population is 50, you're still losing 1 squirrel, having 1 squirrel die per year. If you have 100 individuals, you're likely to have more deaths than if you have 10 individuals in the population, just because it's more accurate to think of death rate as kind of a percentage of the population that dies each year, not a total number that dies each year. I mean, you can get crazy and start thinking about a population of 100,000 individuals. Wouldn't you expect there to be more deaths in a population of 100,000 than in a population of 10? Sure. So we would like to think of death rate as a percentage rather than a total. So let's do that. And to do that, what we're going to do is we're going to add another type of what's called primitive. It's like a stock is a primitive, a flow is a primitive. There's other types of primitives too. One of them is called a variable. So let's add a new variable to our workspace. I can bring it over closer to the rest of the model. And that variable is going to be called the death rate. So we can rename that the death rate, and the death rate is going to affect the total number of deaths. Whenever any variable affects a rate in a stock and flow system, that's going to be called a link. So a flow is an actual flow of material or individuals out of one stock and potentially into another stock. A variable just stores information. This is going to store the death rate and fractional death rate for the population, and that's going to affect the number of deaths. But this dotted line here, this link, is not representing actual flow of individuals. It's just representing a flow of information. So the death rate is being used to inform the total number of deaths. So again, if you didn't catch that, I'll delete this. Oops, that's not the right thing. There we go. I don't know what happened there. All right, so to make a flow or make a link, just click on, make sure the links button is selected there. And then when you drag your cursor across the death rate, you'll see the arrow. Just drag the arrow down to the deaths. And now we have linked the death rate to the total number of deaths. And let's define the death rate. And the death rate, to do that, just again hover over the death rate, click on the equal sign, and that gives you an opportunity to put in a fractional number. I'll say 0.15. That is 15% of the population dies each year. All right, and you can hit apply. And now all we have to do is define how that death rate can be used to compute the total number of deaths. And to do that, hover your cursor over the deaths flow. That is this arrow here, solid arrow, and click on the equal sign. And instead of just putting a number, we can put an equation into the flow rate. And the equation is going to be, take the total number of squirrels and multiply that by the fraction of squirrels that are going to die, which is the death rate, and then hit apply. All right? So now we have a stock, a flow, and a variable, and in that flow, we have specified an equation that computes the total number of deaths each year. So what InsightMaker is going to do is it's going to start with a population of 100. It's going to multiply that using this equation by the death rate to compute the total number of deaths, which is going to be approximately 15 in the first year, it's going to be exactly 15 in the first year, right? Because this is 0.15 times 100 is 15. So you're going to have 15 deaths in the first year, and then you're going to start the next year at a population size of 85, multiply 85 times 0.15, compute the death rate again, and then you'll have that number leaving the population and going into the ether, basically. There's nothing here, and that means death, because it's not keeping track of those individuals past that. It's just going into the background white space, never to be seen again. So let's run it. Let's run this model, and there we go. That is a much more realistic model, because now when the population is bigger, we have more deaths, and when the population is smaller, we have fewer deaths. And what you get is something that looks like an exponential decline. Starting off with 100, it declines fast at first and then slow as it gets towards 0, and eventually the population goes extinct. So that's our first realistic population model. We've introduced stocks, flows, variables, and links. And so all of those are in this model here. All right. Now that we have a good model, let's save it. So just remember to always save your work here. You can save your model. When you hit save for the first time, you can save it as, my first model, Insight Maker model. And by default, it's a public insight. If you don't want other people to be able to see your model, you can make it private. It's your choice. And hit save. So now you have your first saved model. And if you go back to your account and go to My Models, you'll see that this model is now there. And you can return to it anytime in the future. One thing that I'm going to be asking you to do in Insight Maker throughout this short course is to clone insights. And so I'm going to give you a link to a base model. And when I say a link, you see this URL up there. You could share that URL with anybody, and anybody could, if it's a public insight, if you saved it as a public insight, anybody should be able to load your insight and run it. But one thing they can't do is change it. And if I want to ask you to change a model that I started, what you need to do is load that model up. So I'll give you this URL. You can paste it into your browser, and you'll get something that looks like this. But you won't be able to edit it. You won't be able to change the values, say, of the death rate. So what you can do is go to this. I know this is a little bit small to see, but where it says Clone Insight, once you've saved a model, it'll give you this option to clone the insight. You can click on Clone Insight, and that just creates a copy that you own. So I will clone this. You can, if you are serious about cloning it, you can hit the clone button, and now you have a clone of the model that I or somebody else sent to you. All right. So here is my cloned model, and you can tell because if you look up the URL, it says clone of my first IM model. If you don't want the name to have the word clone in it, you can just go to this edit info and rename your model. And so this is, I can name my second Insight Maker model, exclamation point, and hit save. So you can rename models using that technique. All right, so that's most of what I wanted to show you in this initial intro to Insight Maker. I do have one more thing that I want to show you, because in a lot of cases in our PVA work, we're going to be adding random number generators to our models. And so let's add a random number generator into our model. All right, I'm going to add a random number generator onto the death rate. And we'll talk about this more. Don't worry if you do not understand exactly what I'm doing here. Just know that what I'm doing is I'm adding a random component to our model so that every time we run the model, it might look a little bit different. And that's the way in population modeling we can, what I like to call it, is embrace uncertainty, because we cannot really predict the future exactly. And in order to understand the limits of our ability to make predictions, we can use random number generators that help us understand how variable our system can be and how uncertain the future really is. And hopefully that'll become clear as we go through this short course. But first, I will just note that Insight Maker gives you a whole bunch of options in this right-hand panel in the equation editor window. So when you click on that, this is on the deaths flow. So I got rid of the equation I had before, and instead I'm going to add a random number generator. It's called the binomial distribution. It's like flipping coins. I'm going to flip the same number of coins as there are squirrels in the population, and I'm going to count up all the coins that come up heads with a probability equal to the death rate, a probability of coming up heads. Imagine I'm flipping 100 coins and I'm counting up the number that come up heads, given the probability of coming up heads is 0.15 or whatever the death rate is. So that's what I'm doing. It's a random number generator. And now you'll see that there's some randomness here. And if I start the population at, let's see, if I started at 10, you'll even see more randomness in there. All right. So this green line represents the squirrel population, and it goes extinct here at year 18. If I run it again, it might go extinct at a different year. Yeah, it does. So this time it went extinct in year 20. Now, the last thing I want to show you is when you have a random number generator in a model like this, which has this random binomial random number generator, you can use this thing called a sensitivity testing tool, which automatically runs the model many, many times, and you can specify how many times you want to run it. So let's say I want to run 100 times. I want to run this model 100 times, and I want us to look at all the results. And I will hit this button that says plot each run so I can see what each run looks like, all 100 simulations. Oh, sorry. You have to specify what you want to monitor. So I'm going to monitor the squirrel population, and I'm going to do it 100 times, and I'll explain more about what those are later. But I'm going to plot each run. So let's run it. And there we go. And so now we see that sometimes we get extinction, and here I'll go over to the squirrel runs chart. You can see each of there's 100 runs here. And some of them go extinct by year 38, and some of them go extinct as early as year 7, just by adding this little bit of randomness into our model. So now we can say we're uncertain about the future. We know pretty certain that this population will go extinct because, well, there's no birth rate, which there's only deaths. So the population will go extinct at some point. But we're uncertain about what year it'll go extinct in. It could be really soon, in the next 6, 7, 8 years, or it could be within the next few decades. It's hard to say because we're uncertain about the future. And that's the sensitivity testing tool. So we'll use that a lot in class. All right, that's all I want to do with this introductory demo. And we'll start with the concepts of PBA in the next video.